Welcome to day 5, the last day of FastFloward week 1. What an incredible spurt we've made over the past week. Starting with simple interpreted Cadence statements, all the way up to client implementation of the artist app that prints actual non-fungible tokens for users. But this is just the start of our journey. Today, we'll get to add a new feature to the artist app, trading. And in the process, we'll learn how to combine functionality from multiple smart contracts and also a new Cadence concept called interface. Let's make day 5 the best yet. A quick review of day 4 before we get going. We started with the Flow Client Library, or FCL, which is a JavaScript client-side utility designed by Flow, and it provides functionality related to wallets and the underlying JavaScript SDK. For example, with FCL, we can easily integrate wallets that allow seamless user authentication. We can also use FCL Send, a method to interact with the blockchain by sending scripts and transactions. We also use authz as a shorthand for the currently authenticated user when we want to authenticate transactions. FCL automatically converts Cadence types and values into JavaScript equivalents with FCL decode, so you don't have to worry about the mappings between an int8 and a JavaScript number. Flow Testnet provides an easy way to test dApp integrations with live user wallets, specifically using FCL. You can view contracts deployed on testnet with the flowviewsource.com utility, as well as create and fund your testnet accounts because there's no service account available for testnet using the Flow faucet. Day 4 local artist contract contained a new function called withdraw. It allows picture withdrawal from collection resources. Creating a public capability with such a function would be a terrible idea. Everyone could withdraw pictures from your collection. Thankfully, capabilities have this wonderful feature where you can choose how much of a type's functionality you want to expose. When you create a capability by calling link, you provide the capability type. So for example, in this link, the capability type will be a reference to local artist collection. And it'll be accessible through /public/local artist collection. This is good enough if we have no functions associated with that type that are dangerous. But after we add withdraw, we must create a capability differently. And here's how we do it. First, we create an interface that defines a set of fields and functions. So here we are creating an interface called picture receiver. Note that this is a resource interface, but you can also have structure and contract interfaces. Then we modify our resource to note that it implements a specific interface. Again, in this case, picture receiver. Of course, it must also implement the fields and functions required by the user interface. And those are set in the interface body right here. So in this case, we need a deposit function that takes in a picture resource and a get canvases function, which returns a list of canvases. With this setup, we can proceed to use picture receiver when creating our public capability by using the and curly brace syntax. So here we are linking to a type that implements this interface, specifically the local artist.picture receiver interface. And the rest is exactly the same. Okay. I'm going to give you an example of how this works inside a playground. So there's this hello contract that we created, and we have a greeting resource. And the greeting resource, let's say it implements the greeting limited interface. Obviously it does because it has a get greeting function that returns a string. But it also has this set greeting function that updates the self.greeting string. And maybe that's something we want to expose only to the account that is hosting this contract and nobody else in the public. So if we went about and created our link using this syntax for a capability link for a reference to something that implements the greeting limited interface, which is defined right here. Then anytime someone borrows the capability, they won't be allowed to borrow it using just the greeting type. In order for this to work, they will have to use greeting limited. And within greeting limited, we already see that said greeting does not exist. And so we won't be able to mutate this if we're an outside party. Whereas if we're the account holder that's hosting this contract, we'll still have access to our underlying resource in the storage through an authenticated transaction. So this is something that's going to protect your accounts, your customer accounts, from unauthorized access. And learning about interfaces and capability-driven access control is very important. And make sure to learn more about capability-based access control interfaces by visiting the official documentation. We're ready to take our local artist app to the next level by implementing picture trading. The Day 5 folder contains updated code for the user interface as well as a new contract, local artist market. That's right, we're now interacting with more than one smart contract. In fact, by the time we're done with this quest and all of today's source code, we will have interacted with a whole 3 smart contracts, and that's awesome. Let's look at our updated source code for our new local artist app, starting with this new Cadence smart contract. So in the Cadence folder under source, we have 2 contracts, one the original local artist contract and the other one local artist market. We can then open it up, and so this is 2 structures, a single resource and a resource interface, that we then initialize with the account that stores this contract. And let's take a look at each of these structures. So listing is where we store the information about the price and the canvas that's being offered up for sale. And this is going to be a structure because we want to be able to return information to outside parties that want to see, what's up for sale. And it'd be really hard to do that if we had a resource listing. Next up, we have our market, and the market holds a dictionary of pictures, and this is mapping the pixels to the local artist picture. We reference other contracts by using their name after we import them at the top. As you can see, there's 3 contracts being imported. And we have a listings array of our listing structures. We initialize our contract with empty dictionaries and array. And we have to make sure that by the time we're done, we have destroyed our pictures. This just goes back to the notion of taking care of your resources, not leaving them. All right, so now we have a simple function that returns a listings array, and that's going to be helpful for our user interface when we want to see our listings pop up. Then we have 3 methods that are key to interacting with this marketplace. First one is sell. So we actually send a picture to this function. We tell it who's sending it, so providing an address for the seller and at what price we're willing to sell this picture. Then we go ahead and store the canvas information in the dictionary as the key and assign to that key the picture that is being sold. We create a listing that holds all of that information, append it to our listings array, and emit a item posted event. If a seller wants to withdraw their listing and no one has purchased it up to that point, we allow them to do that by calling the withdraw function, which takes in a listing index and some extra seller information to be able to determine if this is actually the seller. All right, so at this point, we make sure that our listing is still there and the listing seller is the same as the seller that's calling the withdraw function. And we go ahead and assign our picture from our pictures dictionary to a variable right here. And we store it in the seller's collection using the deposit function. And lastly, the buy function, which has a precondition, in fact, two preconditions, which is the listing has to exist at that index that's provided, and also the token vault, which we're going to be paying and exchanging these pictures for flow tokens. The flow token vault that's being sent as payment has enough to cover the price. And if those conditions are satisfied, this transaction will continue, or this function will continue. We take our listing, we take our seller vault where we'll deposit the picture, or rather deposit the payment, and then the buyer collection, which is where we'll deposit the picture. Once everything goes through, we deposit the funds, the flow tokens that came in as payment, and we deposit the picture with the buyer, removing it from our dictionary. So this completes the marketplace functionality where you can sell, withdraw your listings, and buy pictures. All right, now in terms of the client side, we have a few changes to flow.jsx, the context. Specifically, we have a post listing function implemented. So this is a thing that you can take a look at when you're implementing your quests to see how to interact with this new contract called Local Artist Market. What we do here is we take a picture from a user and put it up for sale. And in that case, we make sure that we have, and we put it up for sale. To do that, we get a reference to the market from the account that's hosting this contract. And this is, by the way, how we access our env file where we're storing this information. We can take a look at that real quick. So this is the account that's hosting this new contract. And we get at that information using process.env. And this just interpolates variables in strings for JavaScript templates. All right, so we have a market reference, and then we take the collection. Now, our collection is, there's a capability that's created for this collection that does not have a withdraw function exposed. So for that reason, we have to load this collection from our storage, meaning we move it completely from storage. Then we withdraw a picture for these specific pixels and store it in the self.picture for the transaction. And we move the updated collection back into storage, completing this picture withdrawal. We can do this because the account that's calling this transaction has authorized it. And so there's not going to be a problem with that. And finally, we set the seller as the account that's calling this transaction. And in the execute body, if there's a picture, we make sure to sell it, or call the sell method, and we send it the picture, the seller, and the price. One thing to note about the price is that this is a fixed 64 price, meaning we can't just send it an integer. Let's say someone wants to sell it for 11 flow. We have to format our price to have a dot, and even though it's a round number, it's an integer number, we have to format it such that it has some amount of fractional digits. Otherwise, Flow will reject the transaction because it will not recognize the number being sent as a fixed 64 number. Okay, so that's important in this case. This is the only function that's implemented. or rather only transaction that's implemented for the local market, local artist market. The other functions are withdraw listing, which is part of your quest, and buy, which is also a part of your quest. And after you implement these two functions using transactions, you should go to pages, trade, and trade.jsx, and make sure you call the flow.buy with the listing index and flow.withdraw with the listing index, since these are triggered whenever a user clicks on a buy button or the withdraw button. Lastly, I'm going to demo the final version of this app as is implemented with your with the code that's within the day 5 folder. So we're going to authenticate as our testnet user. I'm using morgan@wild.work, and we can see that our collection is empty. Let's draw something. So I'm just going to draw some modern art, and let's print this as a picture. We approve this transaction. Sweet, it came through, and we have a picture in our collection. We can expand and take a look at it. Now, I didn't open up the trade tab just yet because, well, we already had some pictures and we put them up for sale. So we have an F and an A looking pictures right here. And this is a table that will contain all of the listings that are publicly available on the on your market contract. And this just displays the picture, notes the seller, the price, and if you're the seller yourself, the button here will be withdraw. And if you're some other person, then the button will say buy, and you'll be able to complete the transaction that way. If you want to sell, you go to home and you click on a picture from your collection that you want to sell. Click on sell, set the price. Let's do 42.5. Okay. And then it'll send a transaction to FCL, which then confirms it. We can take a look at the arguments. Yep, that looks fine. And send it for processing. Once it goes through, you'll be taken to the trade page, and you'll see your picture as part of this listing. And you can see the price, 42.5, and we can withdraw this if the functionality was implemented. If we go back to home, our collection is empty. That's because pictures are resources and they're moved between the different collections. And that concludes the demo. This is it. Once you're done with this final quest, you're officially a decentralized app developer. Congratulations. So what's the quest? Well, you'll have to implement a couple of transactions to finalize the picture trading functionality. Here goes. W1, Q9. Buy low, sell high. We have to modify the source context flow.jsx file by implementing these two methods, specifically withdraw listing, which calls the local artist market.withdraw, and the buy function, which calls the local artist market.buy. Also, please take a look at the trade.jsx file, which is located in source pages trade, to see if you need to uncomment anything. And with that, you've got yourself an online NFT marketplace. It's been an absolute privilege to guide you on your journey to becoming a decentralized app developer. Week 2 and 3 are coming up, and Jacob, along with Nick and the rest of the team at Decentology, have an incredible amount of content waiting for you. So strap in for the rest of the ride. The fun has just begun. Take care.